Hello everyone. In this chapter, we are going to talk about carrier wide area networks. So we'll first talk about corporate WANs, and then we'll talk about network access, and then we'll talk about the network core, and also we'll talk about WAN optimization. So this is a table showing the differences between LAN, MAN, and WAN. So basically LAN is local area network, MAN is metropolitan area network, and WAN is wide area network. Then LAN is mostly just in a home or in an apartment, in an office, or in a building, on a university campus, and so on. So it's basically the network within a customer premise. And then a MAN, metropolitan area network, in this case, is the network between sites in a metropolitan area, for example, a city and its suburbs. So it can also be considered as a type of WAN, but it's like a little bit smaller. And then a WAN is actually between sites in a region, a country, or even around the world. So that's how people are using these three terms. So we have talked a lot about LAN in the previous chapters, and then we'll talk about WAN in this chapter. So for local area networks, of course, you are doing the implementation mostly by yourself or within your company. Of course, you can also outsource it, but usually it's done within your organization. And then you can choose what technology to use, and then you have to manage the network yourself. And then for MAN and wide area network, usually these are not under the company's or say a university's control. Basically, these are implemented by the carrier, meaning kind of the internet service providers. And the ability to choose technology from a company's point of view is very low. And also the carrier will be the one who is going to manage the network. The organization basically just pay a fee to the ISP and then to use the service, and then the carrier will do the management. So in terms of price, the local area network is highly related to the cost of the equipment and also the implementation that you have. And then for MAN and WAN, basically it's based on the pricing strategy provided by the ISP or the carrier. So it's highly unpredictable, especially if, for example, if there is monopoly in a particular city, then all the internet services are kind of only provided by one company. Then that company can actually set the price kind of freely, right? So it can set a very high price, like if there's no competition. So it's highly unpredictable. These service providers can also charge different prices to different organizations. So there is a large fluctuation. So like even for residential user like in Hong Kong, when you are subscribing to say Hong Kong broadband or some other services, they have very different pricing strategy, even for the same service. Exactly the same service, they may have different price for different customers. Right? So it's kind of unpredictable. And in terms of the cost per bit transmitted, is low for local area network. It's just running on the Ethernet. But then of course when it's across the city or even across country, then the cost will become higher. So the typical transmission speed for local area networks can be 1 gigabit per second or more. And for MAN, that is 10 megabit per second to 1 gigabit per second. And for wide area network, usually is slower, right? 1 to 100 megabit per second. Again, this will depend on the service that you are subscribing to. In terms of the diversity of technologies, then for LAN, that actually is, although you say the company can choose the technology to use, but there are actually not too many technology standards that you can choose. So basically, it's just 802.3 and 802.11, the Ethernet and the Wi-Fi standards. And for MAN, actually you have more technology that you can choose from. And actually for wide area network, there is a lot of different technologies. There is a higher diversity, which we'll talk about later. So in terms of whether the technology can be a single switched or wireless network, for both LAN and WAN actually is possible. It can be a single switch network, right? And then if you think about wireless network, it's also possible, right? If you think about a lot of this WAN, wide area network, you are using, like for example, cell phone, you may be using satellite, right? Then these are actually wireless technology, but of course it's not Wi-Fi, right? Wi-Fi is for short distance for LAN, but then for WAN there are also other wireless technologies. And can it be an internet is also possible. Like you can also set up as like a single network and also like an internet, so internet networking with multiple networks. So both are possible for LAN and WAN. So if a company wants to transfer information between two sites in two different cities, now of course the company can choose to send the information over the internet. Now of course the internet is ubiquitous, that means it's everywhere and it's inexpensive to use. However, it lacks the quality of service requirements of organizations. For example, it does not have the required security or speed that may be needed by an organization. So if you don't want your message or your data to go on the internet, then you may have to have corporate WANs. So when you kind of subscribe these services from, or you try to get these services from your internet service provider, then you will get the required quality of service. So of course, when you do this, you may have a dedicated data line that is allocated to your company, right? Then when you do this, then it's of course going to be much more expensive than the internet because there are various traffic engineering requirements. So normally this one, as we said, will be used for transmission of data between the corporate sites. So next we'll talk about network access. So these are the basic WAN components. For example, a company may have different sites in different regions or different cities. Then the WANs can connect corporate sites or connect a firm to the internet, right? So this will be done through a WAN core, and then this is connected to the ISP. So you have something like this. Like site 1, then you have the access line going to the WAN core. Site 2 also have this access line to the core of your WAN. And this WAN is also linked to your internet service provider. So before we talk about the WAN component in more detail, let's go to an older technology, which is the public switch telephone network, which has been around for more than 100 years, that is used for landline telephones. So basically, if you want to make a phone call at home, right, the telephone, you are using the landline, not using your mobile. Your landline telephone actually is connected to kind of a switch, right? Can be like from your home here, different homes connect to a switch. So this one is a switch as like class 5 switch, and then you have maybe have another class 5 switch connected to other homes, other apartments, and this may be further connected to a higher level switch, a class 4 switch through trunk lines, right? So that's how a public switch telephone network or PSTN looks like. And then when you go up to higher level, there's look like this, like the class 4 switches may be connected to class 3 switch, and there can also be bypass trunk line, right? So the PSTN is a modified hierarchy with the possibility of bypass lines. So that means if you have the bypass line like this, if I want to make a phone call from here to someone who is here, right, connect to this switch, I can actually go through this route. I don't always have to go up to the highest class switch in the network, right? So that's how the public switch telephone network works. And the good thing about this is all these telephone lines have been installed at almost anywhere, okay, in developed cities. Now, of course, if you think about any developed cities in the world, and also like say for example in Hong Kong, then you have all these lines already available. Even for some remote or rural areas, you already have telephone lines. So that's why it's actually quite convenient to use these telephone lines, and also for internet data. So that's why probably around 25 years ago, then people started to think about then this using these telephone lines for internet, right? So the local loop in the PSTN actually brings a one pair wide grade UTP line to every household. So remember we talked about in earlier chapters the Cat5 or Cat5e cable. Basically, there are 4 pairs. But then normally these telephone lines, when they were put there in the very beginning, it was just 1 pair, and some of them were upgraded to like 2 pairs like later on, and of course some are better already upgraded to 4 pairs. But basically, when you talk about 1 pair and 2 pair, they were not designed to carry data, especially in the early days. 1 pair was not designed to carry data, but still, it's possible to use that to send data because after all, it's still 1 pair of copper wire that you may be able to send electricity signals. So there is a technology called ADSL, asymmetric digital subscriber line. So that they use some advanced technology to deliver data over these 1 pair lines. Right. So the lines are already installed, as we said. So the very good thing is there's no need to run a new line to the subscriber, right? Especially you think about rural area, like I don't have to install a line to every house. Like if you think about again like China, US, these countries are large, right? If you want to install a line to every house, it's going to be very expensive. So if you are using the existing telephone lines that were already installed like many years ago, then your ADSL actually can just use this line, so it becomes inexpensive. So that's why it also became very popular in the US and in many cities like around 20 to 25 years ago. So of course the ADSL lines, what you can do is like they design the data, the line the technology in a way that when you download data is faster, because a lot of time when you're browsing the internet you do a lot of downloads, especially in the early days of the internet you are mostly just browsing, going to websites, downloading emails and so on. You may not do a lot of uploading, so that's why usually the downstream data is faster, the upstream data is lower. So that's why we are saying that this one is asymmetric, as we have in the name. Right. So at the same time then you can also have this telephone service. So depending on the technology, some of the older technology, actually when you are using the data, you cannot use the telephone. So you can only use one of them at the same time. But then for some of the improved ADSL technology, when you are using data, you can still use the telephone. But basically the idea is people this technology try to put all these together in one single to support all these in one single pair voice grade UTP. So then you normally like for example this one is at an apartment, right, at home. Then what happens is originally the telephone line is going to be plugged directly to the telephone. But what happens is there's a splitter here that will split the signal, right? And the telephone signal will go to the telephone, and the digital signal will go to the modem, and the modem will basically convert the signal that can be understood by the computer. And then on the other side, at the telephone company, the end office switch, then there's a device called the DSLAM, which actually stands for the DSL, which is the digital subscriber line access multiplexer. So basically the idea is similar. You basically split the signal, right? So that if there's data signal, then it's actually go to the data WAN. Then if it is telephone signal, then it will go to the PSTN. Now of course this access multiplexer is handling the data not for only one customers, but for many customers together. Another way to connect to the internet from a home or from an organization is actually you use coaxial cable. So coaxial cable service was created to bring television to homes that have poor over-the-air reception. So many of these cable TV companies actually find that because they already install the cable lines to the people's home, so they can also use all these cable lines to transmit data. So similarly, what you can do is you just install a modem, right? So you install a modem at your home, and then this modem actually can again split the data. So if it's TV data, then it goes to a TV. Then if it is internet data, then you go to your computer, right? So you have a cable modem that would do this data splitting. Yeah. So this kind of cable service actually is very popular in the US. I think that one reason is in the US cable TV was well developed, so many homes in the US already have the cable TV line, so the cable TV company already installed many of these cables for cable TV in the country to many different places. So that's why again it's easy. They don't have to install too many new lines. They can use the existing lines. So that's why it's very popular in the United States, but not too popular in most other countries where cable TV is not as popular. Like in Hong Kong, we also have cable TV internet services by the Hong Kong cable TV company, right? So they also support that. So it's also using this kind of technology, using a cable modem. This diagram is a coaxial cable. So there are two conductors, which are the central wire and the coaxial ring. So there is an inner wire conductor, and then there is a layer of insulation, and then there is an outer conductor, which is a mesh within the jacket, and then at the connection there is a solid ring at the end. So if you have cable TV, you have seen this kind of cable. So a cable modem service framework basically looks like this. So from your cable television company, right? So this one is like where you have your connection to, right? So they have their connection to their the internet service provider, or they are running it on themselves. So basically, so this one is the connection to the internet, and then they have already installed optic fiber to the neighborhoods, like or other types of wires. The most likely optic fiber for the cable TV transmission, right? And then at the neighborhood, then they have the splitter, so split the connection to different households. And then they also have amplifier, because like the signal may become weak, so they may need amplifier on the way. And then there are thick coaxial cable in the neighborhood, then there will be shared throughput for different people, different households using it in the neighborhood. So that's why a lot of times, if you are installing, like if you are using the cable modem or cable internet service, you'll find the throughput actually is shared by your neighbor. When your neighbors are busy using the internet, then your speed may also be affected. And then there's a thin coaxial cable going to the household. So again, like of course, like at the home, then you need to have a modem that will be able to split the cable TV signal and also the internet signal. Yeah, so this one is the diagram showing the cable modem. Then from the cable modem, you have a line that you can connect to a TV, but at the same time, there is a line like that will connect to your computer or connect to another wireless router. Right? So it could also be running like wireless services if your modem it can also provide that. But a lot of times it may be two separate devices. So just a quick comparison between ADSL and cable modem service. So in general, cable modem service offers somewhat faster individual throughput at a somewhat higher cost, and the ADSL service offers somewhat slower individual throughput at a somewhat lower cost. But of course, like nowadays, especially if you think about it in Hong Kong, people are basically not using cable modem a lot, nor ADSL. We are basically using basically having the um Ethernet connected to your home directly. In a lot of buildings, you already have all those Ethernet cables or other or even optic fiber connected into your home. So for if you are using those kind of service in general, they will be faster than cable modem and ADSL. Now we'll look at cell phone service. So note that a cell is actually a geographical region, while a cell site is a building with cellular equipment. So imagine this one is a city, and then you have different districts that you may be walking around in this city. So when you are here, then your mobile phone actually will look for the nearest cell tower or cell site, and they will try to make the connection here. So that's how you can use your mobile phone in the city, right? Because when you're using your mobile phone for talking or for data, you are not using the Wi-Fi, right? When you are walking around in the city, right? So you'll be actually using the cell phone service like 3G, 4G, and now we are talking about 5G. So a channel actually can be reused in multiple cells, so the carrier actually can serve more customers. For example, if you are using a particular channel here, so another user can also use the same channel in another cell. Right? So that means actually even if you just have 100 channels, you can potentially serve more than 100 customers because they may not be in the same cell. So that's why when you have too many people in the same cell together, for example, in a very crowded area, in a shopping area sometimes, or sometimes in some of the some event site, when too many people are trying to use their cell service at the same time, right, then they will find that they cannot make their call when too many people are calling in the same site because they're in the same cell because they are connecting to the same cell site, and the capacity of that cell site is limited, and also the number of channels available in a particular cell is limited. But in general, if people are not crowded, then your customers you can actually serve more customers than the number of channels you have. So as we said, the same channel can be used in multiple cells. This allows subscribers in different sites to use the same channel. Consequently, the carrier can serve multiple customers per channel. Right, so that's the reason for using cells. So when you have cells, then actually you can serve more customers, and also of course you the limitation of the distance of the signals is also one reason, right? So when we discuss on Wi-Fi, we said we may have multiple access points in the same building, right? Actually, that has the same purpose, because for Wi-Fi you have a very limited number of channels. So, but you can still serve a lot of different people in the same building because you have different access points, and then different people connecting to different access points could use the same channel as long as they are not very close to each other. So for example, if you have 500 channels, given your bandwidth, then only 500 simultaneous subscribers can be served in the entire system if you do not have channel reuse. But if you have channel reuse in each cell, then suppose you have 500 channels, but then you have 100 different cells, then theoretically you can serve 50,000 simultaneous subscribers at the same time. But of course, you have to assume that these users are evenly distributed in the cell, right? And of course, that's also something that this cell service provider have to think about, right? How many cells we need to have, and also how we plan for the maximum number of users in each cell, and so on, right? So because as long as your number of users is over the number of channels in the cell, then basically the additional users cannot connect anymore. So if you travel between cells, you will be handed off to a new cell site in the new cell. For example, you will walk from O to P when you are talking on your phone, or just when you are using your phone to get data. Then you will be handed off from this site O to the site P. This diagram shows how you can make a phone call from your cell phone to a wireline customers or vice versa. So suppose you are walking here in the city and you are using your cell phone. Then you connect to the cell site, and then the cell site may have a connection. Actually, you will have a connection to a what we call MTSO, a mobile telephone switching office. So we will control cell sites, and we will also connect mobiles to the public switching telephone network, your traditional telephone network. So there's a connection here. And of course, as we looked at before, like this one will have connection to the landline. So that's why when you make a cell phone call here, then you will connect to the cell site connect to MSTO to PSTN, and then to the landline customer. So that's what happens when you call from a mobile phone to a landline phone, or vice versa. This diagram shows a mobile phone cell site. So sometimes you will see this kind of thing on top of building. So they may look something like this. So you have some cellular antennas. Then there may also be something like point-to-point microwave antenna to the MTSO. Early cellular systems were limited to about 20 kilobit per second, so it was rather slow. So the actual peak download speeds provided by different plans are roughly like this. 3G, that is like 5 to 10 megabit per second. 4G or 4G LTE is around 20 to 50 megabit per second. And then we go to 4.5G, or what we call LETA, then it might be 50 to 150 megabit per second. And then we go up to 5G, then it can be like several hundred megabit per second. So some of the terms we mentioned, like LTE or LTE Advanced or LETA. So basically, nearly all carriers are now using LTE technology, and then LETA is the next generation of LTE. And currently, for LTE, speeds are required to be 3 gigabit per second downstream, half of that upstream. But this one is the theoretical speed only. The actual bit speed is much slower. And then the 3G, 4G, 5G basically are the ITE definitions of generations. However, some marketers are basically using the terms in a casual manner, so we need to be careful. Right? When people talk to you, their plan is 4G, 4.5G, or whatever. You actually need to look at the actual speed guarantee that they are giving you. Then only from that you can know the actual service that you are getting. The actual throughput differs widely from rated speeds, so there is extensive overhaul in cellular transmission. The data transmission rate is always less than the bit transmission rate. So if the user is riding in a car, then throughput will fall. Right? If more customers are using the cell site, then the cell site might also have to decrease the transmission speed to each user. So in particular, speed will depend on the time of day, because like at different time of day, you have different number of users. If the user travels to an area with an overloaded cell site, speed will be lower, and sometimes you will even be dropped because there's no more channel available, or sometimes the handover did not go through successfully. So at greater distance from a cell site, the speed will fall, just like Wi-Fi. Weakened signal strength caused by transmission through buildings will also reduce speed. So that's why the actual throughput is usually much lower than the rated speed. So now we talk about the network core. So as we said, the WANs actually connect corporate sites or connect a firm to the internet. So we have different sites connect through the core, right? And then this core actually get access to the internet through the ISP. So corporations actually need to connect to their sites with high quality transmission networks with better quality of service than the internet, right? So theoretically, we could also transfer all the corporate data on the internet, say with encryption, right? That is kind of like safe, but then still another problem that you might have is the speed may not be good enough, right? So we want to have higher speed, better reliability, and of course also better security. Like if I really want to transfer my data within two sites, then instead of going through the internet, I may want to have my dedicated connection. So what you can do is you can have listed lines. So you have like this at the layer 1 level, Alright, so you have access lines, and then you can also have your list line networks, and then you can also have carrier Ethernet. So then this is on layer 2, and that means by doing this you extend your site Ethernet length to the corporation. And there's also something called the multi-protocol label switching, MPLS. So it's a layer 3, so it actually involves strong traffic engineering for higher quality of service. So these are some of the core technologies for the wired carrier WAN. So this one is a diagram showing what you may be doing with the list lines. So for example, from different sites here, like site A to site B, then you may have the list line. So the list line, that means the line is kind of dedicated to you. It will not be used by other users. It will only be used by your companies, right? So you have this list line that you could lease from the service provider, right? And then, so this is the list lines. And then here you may go to a multi-protocol switching. Your actual list line may consist of multiple access lines between the different sites. So each customer site must have a CSU or DSU interface to the telephone network. So the CSU, DSU actually are they stand for Channel Service Unit and the Data Service Unit. So these are hardware that converts a digital data frame from the communications technology used on the LAN into a frame appropriate to a wide area network and vice versa. So you need this unit, you need this hardware to do the conversion such that your list line can function on the WAN. So this one is an example showing a list line data network. So you may have different size, and depending on your need, then you may have, and also the technology available, you may have different list line. For example, you may be using a T1 line here, and then a T3 line here, and an OC3 line here, and so on. So you may have different options and different lines that you are using, again, depending on cost and also your need and the technology that you can use. Then at each site, you need to have a router. So you need to have a router at each site, such that because these are, you may be running the different network at each site, right? So you need this router to have the connection between the different networks. So these are some examples of speed for the list line. So in North America, basically they have been using the term T1 and T3. So T1 are basically rather slow speeds line, 1.5 megabit per second. So they are just relying on the traditional telephone line, like two pair data grade UTP. And T3, the requirement is 44 megabit per second. So it is a carrier optical fiber. And then European standard then is more like E1 and E3, so it's like 2 megabit per second and 34 megabit per second respectively. And technology is like also similar, like two pair data grade UTP versus like optical fiber. So fractional T1 speeds are also offered by carriers. So this typically includes some subset of the speeds like 128 kilobit per second, 256 kilobit per second, and so on. And the T1 and E1 lines can be bonded to provide double, triple, or quadruple the capacity of a single line. So of course, those are like relatively older technology actually. So of course nowadays, like if you really need to have this line between corporations, you may be actually going for higher speed that rely on optical fiber. So again, there are different standards like it got different names. Again, one is more like North American standard, one is more like European standard. So you have like OC3 or STM1. So these are like 155 megabit per second. And then of course you go for higher and more expensive standards, right? So like OC768 or STM256, then this one can theoretically go to 39 gigabit per second, right? So it's much faster, right? So now we'll look at the public switch data network PSDN. So a subscriber may have different size, and this different size may be connecting to the different paths, or what we call the point of presence on the PSTN core. Then we need to be able to switch the messages between these sides within this core. So the switching technology used basically is what we call the carrier Ethernet. So again, like Ethernet is also used here, right? So traditionally, actually, there were other technologies like frame relay or ADM. Like some of them actually are not that popular anymore. So some people are still using it, but nowadays I think many people are going for the option of having a carrier Ethernet. That means at this PSTN level, people are also using like carrier Ethernet, like based on the Ethernet technology. So the idea of carrier Ethernet PSTN service is like this. So basically, when you have access line going to the carrier Ethernet provider, so you are just basically having a E-line service that is kind of like a point-to-point connection between the two sides. So you just have to kind of assume that you are basically dealing with Ethernet, right? So you only need Ethernet equipment. So by doing this, you don't need to worry about like other different standards. So it's actually much easier. And this ELAN service extends the Ethernet LANs to cover multiple sites. So again, like even when you have multiple sites, then you, based on what we have this ELAN service, so it's still like kind of functioning like you are having this Ethernet, although it's like technically a wide area network. So again, this is making things much easier for the network administration. So here are some of the benefits of the carrier Ethernet. First, the cost is low. And also, as we said, your network administration staff are already familiar with Ethernet technology. Also, high speeds are available. Also, increases in speed can be provided very quickly. Also, you can have the quality of service guarantee, and also the security is quite good. So now we talk about multi-protocol label switching. So as with the routers, basically route each packet individually, going through the 3 steps that we saw in the last chapter. So even if the next packet is going to the same destination IP address, the router will go through all the 3 steps. So that will actually consume a lot of processing power per packet. As if you don't do caching, so you have to go through the whole routing table for every packet. So this is actually making traditional routing expensive. So that's why people actually came up with this multi-protocol label switching MPLS to address this issue. So routers actually identify the best route for a range of IP addresses before sending data, right? And then the route is given a label number. Then each packet in the stream will get labeled with this label number, and then routers do only a quick table lookup per packet, like based on the label. Then this table lookup requires much lower processing power. So that's why when you do this multi-protocol label switching, it is much less expensive than traditional routing. So this one is a diagram showing how MPLS works. So as we said, in MPLS, a best labeled switched path is set up for all packets before a connection begins. So if I want to send a packet here from this host to here, right? Actually, this label switching router 1 will work together with the other routers and to find out which one is the best path. So once this best path is found, then it will be given a label, and all the remaining packets for this connection will go through this route. So this label switching router 1 will add the label to the packet, and as we said, the label will specify the packet's label switched path. So for example, the label number is 123. So the label actually sits between the frame header and the IP packet header, so like this. So when the next packet comes in, so the label switching router 3 will look up in this table, saying if the label is 123, then I'm going to send the data out on port 1. So based on that, then router 3 will send the packet out through interface 1. So the final label switching router will remove the label from the packet. So neither the source nor the destination host knows that the label switching is being done. So as we said, by using this label, then your routing is much faster because the label lookup table is much smaller than your routing table. So MPLS reduces the forwarding cost and also permits traffic engineering, including quality of service and traffic load balancing. Here are some network core alternatives that we have talked about. So list line networks, company must manage the network itself, so it can be expensive and requires headcount, because a lot of time when you list the line from the ISP, they just give you the line, but then for the actual networking administration, you have to do it yourself. So it can be quite expensive and also require headcount. And when you use the carrier Ethernet, the provider actually would do the management work, and also for the company's networking staff, you are basically using a familiar technology. So also because of the economy of scales provided by the service provider, they can actually lower the price. So the price is actually quite expensive. So MPLS can also be used, so it actually provides the highest quality of service, but it's also much more expensive. So a service may not be available for all sites, although we said that different alternatives, but a lot of times you may not be able to choose because it may not be available from your service provider in your area or so on. So using two or more carrier Ethernet or MPLS carriers may run into incompatibilities that harm your interoperability. If you are spanning from multiple cities, right, then if you are using different services, different Ethernet, different carrier Ethernets, then actually there may be a lot of these problems. So in reality, most companies actually use a mix of list lines, MPLS, and carrier Ethernet or another PSTN to link their sites. So actually, it could be quite complicated if they are provided, if the services are provided by different companies and different providers, and they are using different technologies. So finally, we'll talk about WAN optimization. So for example, you have this two sites that you want to send data 3 gigabit per second and 5 gigabit per second to these two sites, but then your line is only 1 gigabit per second, then there's a problem here. And so one thing that you can do is you can actually do some compression, right? For example, as you said, your data requirement is 8 gigabit per second without compression, but if you could compress the data for 10 times, it will become only 800 megabit per second. That is possible to send it through your 1 gigabit per second line, right? So then if you want to do this, then you may need to have something that we call the WAN optimization device. For example, this one is a 10-to-1 optimization device. Suppose your data could be compressed by 10 times, then it can be compressed here, and then it will be decompressed here, and then sent to your destination. So besides compression, the other thing that you could do is caching. So the first time a large file is transmitted, is sent in its entirety, and is also stored in the receiving WAN optimization device's cache. So the first time when you send this big file, say from A to C, it will be stored here in the cache here. Then next time if C needs to get, or some other sites need to get the same data again, then actually they can get it from the cache instead of asking A to send it again. So as we said, the next time the entire file is not transmitted, it will only send a short message asking the receiving device to send the file from the cache to other destinations. So we can also do traffic shaping and acceleration in WAN optimization. For example, some of the unfavored applications like YouTube, BitTorrent, Netflix, and so on could be blocked or rate limited because this may not be the legitimate use in your company, just the employees browsing the web or sharing files, right? There are many of these traffic could be blocked or you limit the speed like by your WAN optimization device. And then the approved applications like email, your data transmission, and other permitted data can have higher priority and can use this line like better or use this first. With your WAN optimization device, it's also possible to do application and network protocol acceleration through tuning to reduce latency. So that's the end of this chapter. Thank you.